Yes, I'm extremely excited to get a chance to do this because we're talking about Cisco OutShift. And if you're not familiar with OutShift, in a nutshell, I think of it as Cisco's incubation engine. It's the team that is not looking to make $1 billion off of a single product and how to get it in your homes and businesses. These are the guys looking around the corner saying, what's next? How can we best serve our customers and our stakeholders in a way that represents where the technology is going? And yes, I've got Ramana Kompella. How you doing?
Good.
So nice to meet you. You're a Cisco fellow and you're also head of research for
correct.
Cisco OutShift,
That's
correct?
correct, Steve.
So let me ask you, because I want you to explain this, because I'll probably mess it up, but I see you as guys majorly having two big things you're talking about here.
Correct.
You've got Internet of Agents, have you explained that, as well as quantum computing, which simultaneously feels like it's way out there, but yet we need to be paying attention now. How do you kind of square those two? How do they come together?
Excellent, yeah. So I think we're really fortunate to be in this midst of two major revolutions, right? So the Internet of Agents and the quantum internet, and both of them are actually, they have a very interesting commonality, if you will. So Internet of Agents is about interconnecting agents to actually build a fabric so that agents can talk to each other and discover and solve pain points there. Similarly, quantum is exactly that. We have a bunch of quantum processors. The industry is moving towards building quantum computers. We really want to interconnect all of them to really build a quantum distributed data center.
Yeah.
Now, the commonality is, what we are doing here is not about enabling a lone wolf. We really want to enable the pack. So that's the analogy I would like to use, and that's the commonality between both these trends.
Well, and how relevant is quantum networking, because that's what you're specifically looking at, right? Which is, and we're getting positioned for that because these computers that aren't quite here yet, but we're seeing very good things happening. Is it applicable today? Is it something we should be paying attention to now?
Interesting you asked that. So when we actually launched our entanglement chip last May, that was actually, the purpose was to actually build a quantum interconnect for interconnecting quantum processors.
Yeah.
But the moment we put it out there, we have had a lot of inbound customer calls around, hey, what can we do with this entanglement-based network that you guys are building for, that can actually cater to classical applications. And we found a bunch, and actually I've, in my center stage, I talked about a bunch of them. For example, some of the fintech providers, they want to be able to coordinate decisions across multiple trading floors, if you will, and these are constrained by speed of light, and quantum can actually really help bend some of these laws of physics and help them make these decisions in a coordinated manner. Similarly, there are applications like position verification, where you can leverage quantum entanglement and no cloning theorem properties to actually verify the position of where exactly a trade is conducted or what have you in a secure manner. Yeah. Time synchronization, and one other really fascinating applications is to actually verify if there's an eavesdropper on a long-haul communication fiber for improving your security, and that kind of use cases. So
we'll get about 30 seconds left. Internet of Agents, explain what that is, because I had to look up. It's different than MCP. That's really about communicating with resources. But this is really about enabling agents to work with each other.
That's correct. Today agents are siloed. I mean, if you have a procurement agent that needs to talk to a finance agent, that needs to talk to a supply chain agent, these are all they need to be able to come together and actually make sense out of what the common objectives and goals are. And that's what we are really enabling, that substrate that can actually bind all these agents towards a commonality, common goal, and actually achieve complete whatever tasks that you have at hand. And we're doing that through agency, which we actually released to open source, and that's part of the whole
all right, well, I'm going to throw to center stage where we're going to next. Get a chance to come by the quantum area here, because it is important information that you need to know and you need to be on top of.